everybody. In this example, we're looking at topic 3, lesson 1, example 4, sketching a graph from a verbal description. So before this, we've seen the different degrees. We've talked about standard form. We've looked at negative and positive leading coefficients. And so now we're looking at increasing, decreasing versus positive and negative. So how can you sketch a graph of a polynomial function f from a verbal description? Okay, so the first thing we have is f of x is positive on the intervals negative infinity to 4 and negative 1 to 4, which basically means that we're going to have positive y values between negative infinity and 4 and negative 4 and or negative 1 and 4. Right. And then f of x is negative on the intervals negative 4 and negative 1 and 4 and infinity, which again means that my values for y are going to be negative. Okay, the third criteria is f of x is decreasing on the intervals negative infinity to negative 2.67 and 2 to infinity, which means that the slope itself is decreasing. It's going from a greater value to a lesser value. And then f of x is increasing on the intervals negative 2.67 to 2. So let's look at this. I have it nice over here. I pulled out a graph. And I'm going to first mark out my intervals. So I'm going to get this. That's not what I wanted for that. I'm going to get a line. And I'm going to make it dotted. And I'm going to mark out my positive, negative intervals with this yellow. I know it's a little hard to see, but I did kind of just want it in the background. So negative 4, each one of these is going to be 1 unit. So this is a 1, 2, 3, 4. And I put a line there. I'm also going to state my units. So this is 1, negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4. I'm glad I know how to count. All right, so then from negative 1 to 4, we are also positive to negative, which basically means that I cross, or my zeros of the graph are these values, negative 4, negative 1, and 4, because those are the only parts that we can go from positive to negative or negative to positive y values. All right. Then we are decreasing, so I'm going to get a different color for this interval. I'm going to get this dotted line, and I think I'm going to use this light blue. All right, we are decreasing from negative infinity to negative 2.67. So I believe this is 2.67. Roughly, it looks a little bit more like 2.5. So I'm just going to grab this and move it just, move that over just a little bit. There we go. And then we are also decreasing from 2 to infinity. So here to infinity, we are decreasing. F of x is increasing between negative 2.67 and 2. All right. So I'm going to get a crayon here. I'm going to put that we are positive here. And we are positive here. All right, we are negative, I'll use red here, between here and here. And we are negative out here. All right, we are decreasing till we get to this point here. I'm just going to arbitrarily, notice how I didn't put units here. I'm just going to pick a point because this is where you decrease and then we start increasing. I'm going to pick a point there and then we decrease again. All right, so let's see, I'm going to start here, decrease, come back up, increase, come back down. That is a horrible line, but pretend like it is drawn very well. And there we have it. We have a graph drawn per the instructions. And again, when I talk about positive, I'm talking about y being positive. versus y negative. When I talk about increasing and decreasing, you have an increasing slope, or your values are increasing as you go along from left to right, or your values are decreasing from left to right. Okay, so there we have it. There we have our graph. Let's see, their graph is probably a little bit better. So identify your x-intercepts. We found those. Identify your turning points. So there are turning points at 2.67 and 2. Evaluate the end behavior. We looked at that by looking at the positive and negative. And then you sketch the graph. And their graph looks a little bit better than mine, but there you have it. So the common error, positive negative behavior, only tells you where the function's graph lies above or below the x-axis. Sorry about that. It does not indicate whether the function is increasing or decreasing, which is, again, you look at the values. Are the values getting bigger as you go along, or are they getting smaller as you go along? So there you go, example 4.